In this demo, we're going to take a look at using NVIDIA NIM microservices. So again, we'll just take a look here. We've got our LLM deployed here and a few other LLMs. And what we want to do is use our Glue AI Gateway to apply capabilities to the traffic, like traffic shifting and security and rate limiting and so on, to be able to govern LLM usage within an enterprise, especially if you've self-deployed and self-host your LLMs. So in this case, what I'm going to do is focus on a little bit more on observability, the traffic that's going through the system here. So with our Glue AI Gateway, we can expose our telemetry using open telemetry and tie that into Grafana. So if I come take a look at some of the Grafana dashboards here, I can look at the proxy itself, and we see things like the requests that are coming through, request rates, error rates, very detailed information about the traffic. We can also see information about the requests that are flowing through the gateway for LLM usage. So if we take a look here, we can see things like which teams are using which, or how many tokens, and which services are they calling. How is the token usage in terms of prompts and completions changing over time? Do we see tokens being rate limited or semantic caching hits? So why don't we take a look at our sample chat application, and we're going to look at a semantic cache example. So using semantic caching in the gateway, so let me go ahead and deploy this configuration. Again, I'm turning off the security token stuff because we have the gateway handling security on the back end. In one of the other demos, I showed how to apply security to the gateway itself, so the client requires specific credentials. But in this case, we have we just set up semantic caching in the gateway. Tell me about Phoenix, Arizona in the summer in 50 or fewer. And this traffic should be going to our NVIDIA NIM microservice or Llama that's deployed in our cluster here. So if we submit that and we get a response, cross fingers, get a response, and we take a look at the raw view or what happened in the background, we can see in our response, the traffic did end up going and was served by our NVIDIA NIM microservice. Now, if I were to ask this again, and I send it in, then we should see that the gateway will recognize this request came in and apply caching to it, right? We should see a cache hit. In this particular case, I think in the response headers, I don't see too many response headers here. But now if I send this in again, we should see a response. It happened fairly quickly, but if we look at the response headers, the gateway noticed this was a semantic prompt we've seen before, and it's semantically equivalent to whatever's in the cache, and we just return what's in the cache. Now, from an observability standpoint, with the Glue AI Gateway, we can tie into OpenTelemetry and build sophisticated observability tooling, but we can also get distributed tracing. So if I come here to our tracing tool and take a look at the HTTP traces, we can see the requests that just came in for caching. So we see the request came in. We see that it called into some handlers and eventually a semantic cache lookup, and it responded pretty quickly, right? If we take a look at the request before that, this is the one that did not go get hit or hit the cache. We can see this took a number of different calls through our system, and then eventually out to the NIM microservice, and we can see the duration. This was not as quickly. If we take a look at the top level spans, we can see information about the completion tokens that were used, the prompt tokens. In this case, we don't have, I didn't enable the security stuff, so you don't see the user or the team or that kind of stuff. But what we can do, I think, let's see if we can come over here, look at our cluster. Let's see, glue system is 5, so we'll go here. Take a look at our AI gateway, and I think we should see, yeah, we see, whoops, give that a second. All right, here, let me just pause the scrolling here. We can see that we're getting log lines in the gateway itself with specific teams, the number of tokens they're using, what models they're calling. This is being generated from a load generator, tokens that might have been rate limited, what particular user, and so on. So you can take this information, pull it back into your logging systems, and start to aggregate LLM usage across different models and attribute it to specific teams, and start to build things like chargeback or billing systems on top of that. So that's the Glue AI gateway with NVIDIA NIM services running in our Kubernetes cluster here. If you'd like to learn more, check out solo.io's Glue AI gateway or the open source Project K gateway, which is a CNCF project, and try it out and try out the NVIDIA NIM microservices and let us know what you think or how we can improve.